Welcome to video 7.6, type 1 and type 2 errors and power. We're going to use the following scenario to help us remember what a type 1 and type 2 error is and how to interpret it. So Tacos El Canado claims that their giant burrito is 1/2 pound on average, more precisely 8 ounces with a standard deviation of 1 ounce. Luke believes the average weight is less than that. He actually thinks it's 7 ounces. To test his claim, Luke goes to Tacos El Canado and takes a random sample of 5 burritos. He will then test his claim with an alpha level of 0.05. Okay, so for our null and our alternative, so we're talking about means here because we were talking about average and we had standard deviation. That was all our clue that this is a means problem. I'm going to use GB for giant burrito. The claim by the El Canado is they're 8 ounces. Okay. The alternative is Luke thinks they're 7 ounces. So our alternative is we think the mean of the great burrito is less than 8 ounces. Okay, so what do these mean in words? So our null hypothesis means the giant burrito really does weigh 8 ounces on average. That's an average weight of 8 ounces. If that's true, that's what that means. If our alternative is true, it means the giant burrito really weighs less than 8 ounces on average, because we're not talking, it is an average that we're talking about. So if our null is true, if this is actually true, what would the correct decision be at the end of a significance test? Would be fail to reject. Because if this is true, we would want to keep it, so we would fail to reject. If the alternative is true, meaning the giant burrito actually weighs less than 8 ounces, to make our correct decision at the end, we would need to reject the null. Okay, so we can be wrong. It can happen. There is the possibility. And so what that would look like is our type 1 and our type 2 errors. If the null is really true and we reject it, that's a type 1. If the alternative is really true, but we failed to reject, that is your type 2. Okay, so it's doing what you should have done for the opposite hypothesis. So if you find opposite what you really should have found, so that kind of makes sense. You can only get a type 1 if you reject. If you reject, you can only get a type 2 if you fail to reject. You can't get a type 1 if you fail to reject. It's not possible because that's not an error that you could have made. All right, so let's look at what these kind of mean. Type 1 means given your null is true. What did we do? We rejected the null. Okay, given null is true, we rejected it. Now, how to interpret this? This is what's most likely to come up that you would have to do. Use the same format and kind of make a math lib out of it. You'll say, given the null is true in context, so whatever that is, you're going to plug that in. What happens? We rejected the null in context. So it's the same kind of format. We're just adding a little bit more to it and add some context to it. Given that the null is true, we rejected it, and then you want to make sure you include your context. So in this context, we would say, given the giant burrito has a mean weight of 8 8 oz. 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 We reject the claim of 8 ounces. Okay, so it's not a ton of words. You're going to get right to the point and say it. It makes it easier to just kind of get it out quickly, and helps you really zero in on the message you're trying to convey to your reader. So that's type 1. Given the null is true, we rejected the null. Type 2 is given the alternative is true. So given that your alternative is true, what would happen is that we failed to reject. I'm going to use FTR for failed to reject the null. So to interpret that, we're going to use the same idea that we used up here. Given the alternative is true in context, we failed to reject the null in context. You've seen on the rubrics how they're specific about wanting to have the context in there, so make sure you include it. So for this scenario, we'll say, given the giant burrito has a mean weight less than 8 ounces, we failed to reject the claim the mean weight is 8 ounces. Okay, hopefully this is a little cleaner way of thinking of how you would interpret your type 1 and type 2 errors. It gets you straight to the point, helps you deliver your message. Okay, so let's go through our kind of organizer down here of our truth statements and what kind of errors you can get out of them. So the overall truth, is the null true, is the alternative true? So if our null is true and we reject the null, that's your type 1. Okay. If your null is true and you fail to reject the null, that's exactly what you wanted to have happen. So that's a good thing. I want to remind you that the probability of a type 1 error is your alpha level. So alpha 0.05 is a 5% probability of making a type 1 error. Okay. Now, let's go over and look, what if our alternative is true? If our alternative is true and we reject the null, that's exactly what we want to have happen. So I'm going to put my little smiley face over here. And what that is that's where your power comes in. That is how well does the test detect for the alternative. Okay. So, and I want to remind you there, talking about power is the probability. So probability of type 2 is 1 minus power. You should be given power, and you do not have to calculate it. I've not seen it calculated. I've seen it on one test in many, many years. Okay, so probability of a type 2 error is 1 minus power. Okay, and if your null is true and you fail to reject your null, that's your type 2. All right. So let's have a couple quick reminders about power too. So in this case, our power was 0.723. You should be given this number. If you're asked to interpret it, the basic idea is you want to say, because the power is about the alternative. being true. So given my alternative is true in context, well, what would happen? What we're talking about here is the power. So there is blank probability, and in that spot, that's where you're going to write whatever your power value is of correctly rejecting the null in context. If your alternative is true, you need to reject the null. And the probability of that happening is whatever power is. So in this situation, we have given the giant burrito has a mean weight of 7 ounces. Now, let's talk about that for a quick second. Has a mean weight of 7 ounces. That 7 ounces came from the original problem. Up here, that's what Luke thought it was. So you have to use the specific alternative, what the statistic is that you think it is, okay? Given that the giant burrito has a mean weight of 7 ounces, there is a 0.723 probability of correctly rejecting the claim of 8 ounces. All right. Okay. So hopefully that's a easy enough one for you to remember. Now to increase power. The one thing you can do is increase your sample size pretty much whenever you're in doubt of what can you do to increase something. If you want to increase it, you increase sample size. If you want to decrease it, decrease sample size. That's almost universal, it seems. And then another way we can increase power is to increase your alpha. Power and alpha have the same relationship. Increasing one increases the other. All right, hopefully that was helpful. Let me know if you have any questions. I'll see you in class.